Welcome to video presentation on median. Now let's divide this discussion into two parts. In the first part, let's learn how to calculate median, and in the second part, we will see how to apply median in real life example. So suppose we have a data set. Let's say our data set is uh, it's 10, 5, 8, 12, 1, 2, 3, 4, and 15. Let's say this is a data set. Now you can see that in this data set we have 1, 2, 3, 4, and 5 values, right? It means that what? It means that it contains even values, even number of values. 1, 2, 3, 4, sorry, odd number of values. I'm really very sorry. It contains odd number of values because it has 5 values. Now what you have to do is whenever you have to calculate median, whether the data set contains odd number of values or the data set contains even number of values, in all the cases you first have to arrange your data set either in an ascending order or in a descending order. Let's arrange this data set in an ascending order. So if you arrange this data set in ascending order, then this will be, which is the smallest number? The 5, then 8, then 10, then 12, and then 15. Okay, so 5, 8, 10, 12, and 15. Now we have 5 number of values, right? This value, that is a third value, first, second, and third, will be the middle of this data set, right? Because we have 5 values, so 2 values are towards its left, and 2 values that are greater than 10 are towards its right. This is the center. This is the middle of this data set, and this will be the median of this data set. This will be the median of this data set, where 2 values that are 5 and 8 that are less than 10 are towards the right, and 2 values that are 12 and 15 which are greater than 10 are towards its right. Now this will be the median. Now let's take a data set which has even number of values, and let's say we have the data set as we have 10, we have 12, we have 14, then we have 5, then we have 20, we have 25, we have 24, we have 22, 1, 2, 3, 4, 5, 6, 7, 8, then we have 30, and we have 28. Let's say this is our data set where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have even number of values. Okay, again, as we discussed, that doesn't matter whether number of values in a data set are even number or odd number. What you have to do first is you will have to arrange the data set in an ascending order or descending order. So let's arrange this data set in an ascending order. So if you'll arrange it, which is the smallest number? 5. Then you have 10. Then you have 12. Then you have 14. Then you have 20, 25, 24, 22. You have 20. Then you have 22. Then you have 24. Then you have 25. Then you have 28, and then finally 30. Okay, This is our data set. Now, in this data set, there are 10 values, this 1, 2, 3, 4 and 5, this 5 here, and then 1, 2, 3, 4, 5 here. When we had odd number of values in a data set, then in that case we could easily find a median by finding the middle number, right? The middle value. But in this case, where's the middle value? These values are 5 in number and these values are 5 in number. What to do? Okay, what you'll do is first take these values, right? Let me show you how to do this. Control C, Control V. Okay, and then Control C, Control V here. You don't have to do Control C and Control V. I'm just, simplifying it so that you can better understand. Okay. So this is the condition. Now 5 values here, 5 values here. What will happen is your median will lie somewhat here. That will be in between 20 and 22. This will be the median value. And what will be the calculation for that? What you have to do is just simply take arithmetic mean of 20 and 22. Take arithmetic mean of these two values. So if you take arithmetic mean of 20 and 22, then this will be 20 plus 22 divided by 2, and this will be 42 divided by 2. This will be 21, right? So 21 will be here. In this case, your median value is what? 21, right? So median value will come here, that is 21. This is your median value. Let us take one more example for the same even number of values. Let's suppose our data set is something like 50, then you have 25, then you have 20, you have 5, you have 10, you have 30, you have 90, you have 28. So 1, 2, 3, 4, 5, 6, 7, 8, right? And we have 100, you have 95, 2 to 4 to 6 to 8 to 10. Let's take two more values. Let's take 40 and let's take 45. So we have 12, a data set containing 12 values. Now, when you have to calculate median, always remember first arrange either in an ascending or descending order. So when you arrange this data set in an ascending order, then which will be the smallest number? 5, then 10, then 5, 10, then you have 20, then you have 25, then you have 28, then you have 30, then you have, of a 30, you have 40, then you have 45, 45, then you have 50, and when you have 50, then you will have 90, then you will have 95, then you will have 100. 2 to 4 to 6 to 8 to 10 and 12. Yes, done. Okay, so we have arranged this data set in an ascending order. Now 1, 2, 3, 4, 5 and 6, these are 6 values, and 1, 2, 3, 4, 5, 6, these are 6 values. Of course, your median will lie somewhere here between 30 and 40. And what will be that value? All you have to do is simply take median arithmetic mean of 30 and 40. So if you take arithmetic mean of 30 and 40, this will be 30 plus 40 divided by 2. and this will be 70 divided by 2, that is 35. So 35 is a median in this case, is a median. Okay, now let's discuss the second part of this video, where we said that we will discuss the use of median in the real world. Now, suppose this is a data set which represents annual salary of a group of 5 people. So the first person earns 3 lakh per annum, the next person 3 lakh 10,000, the next person 3 lakh 20,000, the next person 3 lakh 30,000, and the next person 3 lakh 40,000. Now, suppose if someone asks you that you have to calculate the average, you have to calculate the average annual salary for these 5 people. Now, this data set is really very small. In the real world or in the real life examples, we do not handle such small data sets. In fact, we have to deal with very large data sets, very large data sets. But still, in order to explain you that what is the real life use of median, we have taken a very simple example. So, if it is asked you that what will be the average, so you will say that, hey, I cannot apply mode here because every value is different, and we can apply arithmetic mean in order to calculate average because the salary varies between 3 lakh and 3 lakh 40,000. So in order to tell the average, you will say that let me calculate arithmetic mean. So you will see that arithmetic mean will be 3 lakh 1 2 3 4 5 plus 3 lakh 10,000 plus 3 lakh 20,000 plus 3 lakh 30,000 plus 3 lakh 40,000. Now if you divide this by 5, you'll get, if you add these numbers, then you'll get 16 lakh 1 2 3 4 and 5 divided by 5, and this will be 3 lakh 20,000. This is arithmetic mean in order to calculate average of this data set. Okay, and this arithmetic mean is telling you the average. So this 30 lakh 20,000 is the average annual salary for this group of 5 people. Now you can say that, hey, you know what, even I can use median also in this case. Yes, very true, you can use median also. So if you look at these values, then you will find that these values are already in an ascending order. Starting from the 3 lakh, you have 3 lakh 40,000. So here you don't need to rearrange it, it's already in an ascending order. Now, what will be the middle value for this data set of 5 values? You'll see that, hey, since this is odd number data set, therefore this third number, because there are 5 values, this will be the middle of this data set, that is 3 lakh 20,000, and this 3 lakh 20,000 is actually a median, and this is our average monthly salary for this group of 5 people. Now notice one thing, in this particular example which we took, even the median is coming 3 lakh 20,000, and even the arithmetic mean is also coming 3 lakh 20,000, but it doesn't happen always. In this example, the coincidence happened because we took such example. So in order to calculate average, you use arithmetic mean also, you use median also. But wait a second, imagine this particular data set of 5 people has now one more person in this one. So now your data set is something like this. It is, let me copy it here. It's, now this time the data set is something like, after 3,40,000, now you have one person in this group who earns 1 crore, 1 2 3 4 5 6 and 7, 1 crore annually. So previously we had 5 people, they are here also, but one extra value has been added of the 6th person who earns 1 crore annually. Now you have to tell average annual salary for this group of 6 people. What you will do? Will you calculate arithmetic mean in this case? Calculate. If you try to calculate, let me show you what will happen. In this case, you saw here your arithmetic mean when you try to calculate average came 3,20,000, and that is really very wonderfully placed. It is between 3 lakh and 3,40,000. That's perfect. Now try to calculate arithmetic mean for this one. If you try to calculate arithmetic mean of this particular, all these values, so this 16 lakh, and when you will add here, so this will be 16 lakh, previous one 16 lakh 345 plus 1 crore 3 4 5 6 7 divided by 6, this will be 1 crore 16 lakh 1 2 3 4 5 divided by 6, and when you will divide this, the answer will be something like 19 lakh 33,333.33. I should not actually place this comma here, that's why. Okay, 19 lakh 33,333.33. If we look at this number now the average annual salary is coming something around 19 lakh. Is that correct? No, because most of the people in this group are actually earning between 3 lakh and 3,40,000. Therefore, if you have to calculate the average of these 5 people actually, because most of the people are earning between 3 lakh and 3,40,000, therefore there is no chance that the average should come around 19 lakh. That's wrong, right? But why did this happen actually? It happened due to this extremely large value which swayed the outcome, which knocked off the numbers, the outcome, and such values are called outliers. Whenever in a data set there is outlier or outliers, then you will not use arithmetic mean in that case, otherwise your final outcome will be swayed. Of course, in this data set only one person is earning 1 crore annually, but all 5 people are earning actually between 3 lakh and 3,40,000. So what should be the way? The way was take help of median. Now if you try to solve for median, 1 2 3 4 5 6, no need to arrange them in an ascending order or descending order because they are already in an ascending order. So 3 here and 3 here, these 3 values here and the next 3 values here, your median will come in between these 2 values. So what you have to do, you have to calculate arithmetic mean of 3,20,000 plus of 3,30,000. You have to calculate arithmetic mean of these 2 numbers. Divide by 2. If you calculate it, this will be 6 lakh and 50,000 divided by 2, right? And if you solve it, this will come 3,25,000. Now look at this value, the median value. It still is showing a very accurate measurement of average annual salary for this group, where most of the people are actually earning even less than 4 lakh, even less than 3,50,000. It's between 3 lakh and 340,000. Therefore, there's no way that your average calculation should exceed 3,40,000. It should be in between these two, right? So this median 3,25,000 is the average in this case. In this particular case, if you use arithmetic mean where an outlier is present, that is extremely large value, then your outcome will be swayed, right? The outcome will be knocked off. So we learn using a real life example that what is the importance of median while calculating average over arithmetic mean.